We will solve some problem based on the selective precipitations. We know the concept of selective precipitation very well, that we are getting some salts are dissolved in the solutions, and one by one salts are getting precipitated by using the excess other substances dissolved in the solutions. On dissolving the substances having a less KSP value will precipitate first. So on that basis of that concepts, we'll see some problems. So this will help you in understanding the meaning of this practical application for selective precipitation. So an aqueous solution contains 0.1 molarity of barium ion and 0.1 molarity of calcium ion. So calculate the maximum concentration of sodium sulfate at which one of them is completely precipitated, almost completely. So what percentage of that ion is precipitated? So KSP of barium sulfate is 1.5 into 10 power minus 9, and KSP of calcium sulfate is 2 into 10 power minus 4. So these two ions are dissolved in some solutions. Okay, these two ions are there. So when sodium sulfate is added, so on adding, what happens? They become barium sulfate and calcium sulfate. So which will precipitate first? So that is KSP is given. So from that KSP, we will find out which ion will precipitate first. So first, right here, what is the concentration of sulfate required to precipitate the barium? So this is required. To precipitate barium ion. Okay, so we can write the KSP value. So KSP value of barium sulfate is 1.5 into 10 power minus 9 and divided by the molarity of the barium ion. So molarity of barium ion is 0.1, so it is given here. So 0.1 molarity of barium ion. So on solving, we will get here 1.5 into 10 power minus 8. Similarly, sulfate for the required to precipitate which ions? Here we have ion, one is barium, next is the calcium. To precipitate which ion? Calcium ion. So right here, calcium, CO2 plus calcium ion. So here, what is the KSP they have given here? So 2 into 10 power minus 4. So 2 into 10 to the power minus 4 and divided by concentration of this is given here 0.01 molarity. So on solving, we will get here 2 into 10 to the power minus 3. So we can compare between this and this. So this is a lesser value, this is a more value. This means barium sulfate. So this means that barium sulfate will precipitate first. Barium sulfate will precipitate first. Why? Because less solubility value. So here what will happen? This is less here, this is more here. So definitely this will precipitate first here. Now we have to find out the maximum sodium sulfate required for the precipitation of barium ion. So what is the next is we have to find out next maximum sodium sulfate is required. Okay, it is required to precipitate what? Barium sulfate ion fully. This means completely. Okay, so completely. So how much we will add sodium sulfate to precipitate barium sulfate completely? Okay, so here this starts, we can see here calcium sulfate starts precipitation when they will reach more than these ions. Okay, because before that barium sulfate was precipitating. Okay, so if you take this concentration of as a sulfate ions, this concentration of sulfate ion, then what will happen? Maximum barium will precipitate completely, because this will be soluble and others will be precipitate completely. Okay, so we can write here. So at this concentration, if you take here 2 into minus 3, matlab at this concentration, at this we can write here at this concentration. Okay, what happens? Barium sulfate will precipitate completely. Okay, barium sulfate will precipitate completely. So how much barium is left? This is the maximum precipitation. So we can write here barium 2 plus, that is left in the solution. Barium 2 plus left in the solution, that is the KSP by here sulfate ion. Okay, so in this cases, so here is barium sulfate. So KSP already we know that it is 1.5 into 10 to the minus 9 and divided by 2 into 10 power minus 3 we have taken. So this is the actually sulfate of calcium actually, but in this case we will find the barium ion. So we will get the barium ion on solving, that is 7.5 into 10 power minus 7. So this is the concentration of barium ion which is left in the solution. So now we can find out the percentage of barium 2 plus left. First we find left, how much amount left. This is soluble in the substances. So left will be your 7.5 into 10 to the power minus 7. Okay, so this is the solution left in the solutions, and the initial was 0.1 molarity, that is initial was there, it is given here 0.1 molarity and multiplied by 100. So we will get here 7.5 into 10 to the power minus 4 percentage. So we can write here percentage of barium precipitated. This is soluble in the water, so precipitated will be how much? It will be your in terms of percentage given 100 minus 7.4 into 10 to the power minus 4. So we will get answer here 99.9992%. So this much barium will be precipitated. So we have to put a small value. First we have to find the sulfate ion of each, then we can find the which has less one, and then after that for the first precipitation of the ion you take the sulfate, that is the ion of the second value, then you will get this one maximum solubility of that barium ion, and then last we can find the this one percentage of barium left in the solutions and take the precipitation. So in this way we will get the maximum precipitator of barium, not calcium. Okay, for calcium precipitation we require third ion. Okay, that we will see the problem in next step. So here we will see the second problem. 0.01 mole of silver nitrate is added to 1 liter of a solution, which is 0.1 molarity in sodium chromate and 0.005 molarity in sodium iodate. Calculate the mole of precipitate formed at equilibrium and the concentration of silver ion and iodate ions and chromate ions. So Kp of silver chromate and silver iodate is 10 to the power minus 8 and 10 to the power minus 13 respectively. So here we have to find out. So again see here it will go under the same things. So first we have to find the which iodate this one or chromate will precipitate first. So Kp of potassium chromate and potassium iodate is given over here. So first we'll find in which case silver is required very less quantities. So first for the let us find out the silver on adding of the silver nitrate, that is nothing but the 0.01 molarity. So when you add 0.01 molarity, so how much silver is dissolved in the solution? So here again we have given here 0.005 molarity of iodate and chromates will do 1 by 1 respectively. So here silver iodide is needed. First we will find on this one. So for silver iodide IO3. Okay, so for this Kp value is given here 10 to the power minus 13 divided by, and here the chromate value is given here, sodium iodide given here, so 0.005 molarity. So on solving we will get here 2 into 10 to the power minus 11. Similarly for silver chromate. Okay, so how much here silver require? So here silver require is 10 to the power minus 8 and divide by 0.1. Okay, so but in silver chromate we can see it is Ag2CrO43. This is Ag2CrO43 for silver requires, so we have to take the square root of this one also. So on taking square root, this become 3.16 into 10 to the power minus 4. Okay, now if you compare this one silver iodate and silver chromate, so this will precipitate first. This is clearly that this will precipitate first. Okay, so this will be more soluble. So if you put silver nitrate continuously, the silver iodate will precipitate first, and if the concentration of silver become this much, then this will start precipitations. Okay, so we have to find the silver iodate precipitate, how much it is precipitated. Okay, so in order to precipitate, we can write here in order to precipitate AgIO3. Okay, so we can write here silver nitrate. Okay, it will react with sodium iodate. Okay, it is giving a silver iodate and plus sodium nitrate. Okay, so initially concentration was 0.01, here concentration at 0.005, this will be 0 initially. Okay, so what will happen after reaction, this will becomes 0.01, so here it is 0.05, so this will be here 0.005, this will be also 0.005, so we get the concentration silver iodide, and this will be 0 and this will be half of, so if you subtracting, if you give here 0.005. Okay, now the left mole of silver nitrate, so this silver nitrate will now precipitate which one? Silver chromate. So right here next equations, silver nitrate, okay, plus Na2CrO4 and plus it will give you Ag2CrO4 plus 2 sodium nitrate. So here this was the left here, so you put this value over here 0.005, 0.005, this is given here 0.01 molarity, and this will be chromate we here initially 0, so this will become, so here 0.1 molarity and 0.05 molarity. Okay, so here we require chromate, so already 2 is there, so we have to take half, we have to, already 2 is there, so we have to take half of chromate, so it will become half, so half will be 0.005 by 2, so that is nothing but the 0.0025, this will be again 0.0025, not point, this is your 0.005. Okay, this is the half. Now this will be your how much? The 0.1 minus 0.025, so this will be your 0.0975, and this will be your 0. Okay, so this will be completely precipitate this one into Ag2Cl3. So we can see here how much chromate is left in the solution. So chromate left in the solution will be how, in solution will be how much? It will be given here 0.00975. Okay, so this is the chromate which is left in the solutions. Now, so we have 3 ions. One is silver chromate. Okay, one is your this chromate ions, silver chromate is there, also there. Then one is your sodium chromate ions is also present there. Okay, so how much iodide left in the solutions? So chromate left in solution. Now which are the solution contents? So here solution has AgIO3. Okay, this is in soluble form. Next we have Ag2CrO4, this also soluble form. Okay, and third we have CrO4 with sodium. Okay, this is in solution form. Okay, so this is given here 0.05. Okay, we can see here 0.05, this is the concentration, this is present in solution. Next this is present in, this is present in solution, and silver chromate here 0.0975. Okay, and chromate ion is present in the solution as a 0.0975. Okay, so we have, so this is not 0.05, this will be your 0.025. So we can write here, cut it here, this will be your 0.000, no, 00, it should be 25. So we can take this value, the 3 values are there which is present in the solutions. Okay, now next is how much silver left in the solutions. Okay, so to find the silver left in the solutions, so we can write here silver left in the solution will be how much? So we can write here K2 Cr2 Ksp of silver to CrO4, it is given here, and divide by the CrO4 2 negative. So we will get here answer. So this is Ag2CrO4, this Ag2CrO4. So we can take a square root, 10 power minus is the Ksp value, and divide by 0.975. So we will get here value 3.2 into 10 power minus 4 polarity. So this is the silver left in the solutions. And next is the how much IO3 iodide is left in the solution. Okay, so again for this iodide left in the solutions, we have to take the concentration of silver. So here Ksp is given here. Ksp, if you see, it is given here silver iodide minus 30, and divided by, this is the solution of silver. So right here minus 4 molarity. So on solving we will get here 3.1 into 10 power minus 10 molarity. So iodide in left hand solution this much and silver left hand solution is this much. So if you multiply it, we will get the value of silver iodide. So this is our basically answers. So a solution contains a mixture of silver plus 0.1 molarity and H2 2 plus 0.1 molarity. So which are to be separated by selective precipitation. Calculate the maximum concentration of iodide at which one of them gets precipitated almost completely, and what percentage of that metal ion is precipitated. So we have given two values, Ksp of silver iodide and Ksp of mercury iodide, both are given here. So we will do the same way. First we have to find which iodide will precipitate first. So those who have the less value will precipitate first. So for we find out for silver iodide. Okay, so what is the concentration of iodide? We can see here. So first concentration of iodide will be Ksp of silver iodide. Ksp will be here. So first Ksp will be how much? The Ksp will be your 8.5 into 10 power minus 17 and divided by concentration of silver is given here 0.1 molarity. Is given here 0.1 molarity. So on solving we will get here answer 8.5 multiplied by 10 to the power minus 16 molarity. Second case for Hg2I2 silver mercury iodide. So here in this case concentration of iodide is, this square is there. Okay, so we can write here concentration of a square. So this will becomes, so Ksp of this is given here 2.5 into 10 power minus 26 and divided by concentration of silver is iodide is here again. Mercury is given here. So this is Hg2I2. So this will be your 0.1 0.1. So this is square is there, so you can write here square. So on solving we will get here answer here Hg2 plus. So this is your not square, this will be your Hg2 plus, means this is nothing but the Hg plus sign. So just take care, so we can't take a square here. So if you write here, it will becomes here 5 into so here is 5 into 10 to the power minus 13 molarity. So this is the basically answer. So here we can't take a square, this is this curve, just take in mind. So this is the iodide of from mercury, this molarity, this is the iodide of mercury, this is, so now we can compare which is lesser, this is less, because this will soluble first, so, and this will precipitate first, and this will precipitate later on when it will reach this much concentration. Okay, if you take this much iodide is a concentration this much in this here, so we will get the maximum precipitation of silver iodide. Okay, so for again we write here for maximum precipitation of maximum precipitation, so we can this will precipitate first. Okay, definitely lower value. So for maximum precipitation of silver iodide, what we have to do? So we have to take the value of this much concentration. If you take this much concentration of this one silver, so we will get the maximum concentration of silver iodide. Okay, so percentage of, we can write here silver left in the solution. So write the Ksp value of this much 8.5 into 10 to the power minus 17 and divided by 5 into 10 power minus 13. Okay, so now on solving you will get here 1.7 into 10 power minus molarity. So this much silver is soluble in the solutions. So again now we will go through, this is soluble in solution, so this maximum. After this silver mercury iodide will precipitate. So now we can write here, so 0.1 molarity for silver left in the solution. How much left? 1.7 into 10 power minus 4 molarity of silver ion. Okay, so percentage of silver left will be how much? So 1.7 into 10 power minus 4 and divide by what is the initial concentration of silver, that is 0.1, and again you multiply it by 100, so we will get answer here 0.17% molarity. So percentage of silver precipitated, this will be how much? 100 minus 0.17%. So we will get answer here 99.83%. So this is basically our answer. So it is if we solve it, I am repeating. First we will finding AgI and H2I2 in which is more which will be more precipitate. So this is lesser value, this will precipitate first. Okay, to get maximum precipitation of silver iodide, we have to take the silver this much concentration. If you take this much concentration, that much silver is left in the solution. Okay, so how much other precipitation left? Precipitated, other silver is precipitated. So this is the soluble silver. So you just divide it, you will get in terms of percentage. If you take 100%, because that is 100% precipitated. So 100 minus this much, so 99.83 is silver iodide is precipitated. For the second precipitate H2I2, we have to take the third one. Then that will give you the maximum precipitation of H2I2. So that we have seen other type of questions.